This is problem 7 from the Physics G mock test. And for problem 7, you're going to use these formulas. You're going to use force of gravity is G m1 m2 over r squared. You're going to use the force, centripetal force is mv squared over r. And you're also going to use that centripetal force is m4 pi squared r over t squared, right? The acceleration here is v squared over r. The acceleration here is 4 pi squared r over t squared. And then basically we're using F equals ma, like this. And then this page, this problem, is a orbit problem. And in an orbit problem, you are, let me just check the final here. I can give you some other clues. But I'm pretty sure that's what it is. I think it's all orbit. Yeah, there we go. Yeah, it's all orbit. There's a conceptual question about black holes, of how, if they have no more mass than the stars they once were, how is it that they generate a strong gravitational field, is the question. Okay. But yeah, let's work through the mock test, and then here we have it. So the first question is, what's the force of gravity between the moon and the planet? I'm just going to use this guy. So for this is not 6, this is 7. I'm going to go G m1 m2. So G is, so that's 6.67 times 10 to the minus 11th Newton meters squared per kilogram squared. And then the planet is 3.5 times 10 to the 24th kilograms. The moon is 7.26 times 10 to the 21st kilograms, and then the radius is, or the distance between them is 3.4 times 10 to the 8th meters, and then don't forget to square that one. First or second, yeah. Yeah.
Do you prefer either?
Doesn't matter, just get here at the beginning of it. 6.67 e to the minus 11th times 3.5 e to the 24 times 7.26 e to the 21 divided by 3.4. Have a good weekend.
Yeah, you too.
8, and then square that, right? So what I'm typing into my calculator is physics 6.67 e minus 11 times 3.5 e 24 times 7.26 e, and then divided by 3.4 E8 squared. And you don't even need to put parentheses around that, I promise you. And this gives me 1.46613 times 10 to the 19th newtons, which is the answer. And then the question is, what is the moon's orbital velocity? It also asks, I think on the test, what's the acceleration of the planet? And there are two ways to do it. So most people are going to get like the orbital velocity because they've got a canned formula for that. But you can also, on the next question, what's the acceleration? Well, F is just ma, right? And the mass that you do, if you want the acceleration of the moon, use the moon's mass, right? And I can go that divided by the moon's mass, 7.26 E21, and you get, like, it's a small number, right? 0.00201 or something like that, right? But the mock test asks, what is the orbital velocity? So to solve that orbit problem, we go G, mass of the planet, mass of the moon, divided by r squared is the mass of the moon times v squared divided by r, right? And now we just solve this. The moon's mass, since the moon is the satellite, its mass cancels. The planet mass stays, right? Everybody's going to like keep the moon's mass in there. It cancels, right? I can cancel one of those r's, and then of course now I just have to square root, right? So it's going to be the square root of g times the mass of the planet over r is our velocity, right? So literally on my calculator I'm going to type square root left parenthesis. This is the planet mass, so I'm going to use 3.5. Oh wait, g, I got to put g in there, right? 6.67 e minus 11 times 3.5 E24 divided by the radius, which is 3.4 E8, right parenthesis, right? So square root, left parenthesis, 6.67 E minus 11 times 3.5 E24 divided by 3.4 E8, right parenthesis, and that's 828 meters per second. Smiley face. I don't think anyone's going to do this problem, but hey, in case you do.